Hello and welcome to the first demonstration video of the first release version of Sovereign Boot Provisioning Wizard. This is the version 1.0.0 which completes the initial development of the whole project. And with this video I would like to introduce you to the new changes to the Sovereign Boot Provisioning Wizard application and what has changed since the past release and what new features have been added. So let's start. Here I have the QEMU firmware based on the Dasharo core boot distribution with the Sovereign Boot Provisioning Wizard integrated. So whenever the system is booting for the first time or its settings have been reset to defaults, the Sovereign Boot Provisioning Wizard will be unprovisioned and will welcome us with this window. This is where we have to choose what kind of UEFI Secure Boot scheme we would like to use. So we have the option to use the standard Secure Boot with Microsoft certificates, but of course we would like to use the Sovereign Boot. So when we select the Sovereign Boot, we'll be presented with the bootloaders that the application detected on the connected hard drives, and we will be prompted to trust these images or the certificates that are present inside these images. What hasn't changed is that the wizard will not show us any certificates that are already untrusted or trusted, and would also not show any images with Microsoft certificates. What has slightly changed is just the visual representation of the buttons, which previously were rounded with square brackets, but right now are simply suffixed with a right arrow. But otherwise the functionality hasn't changed. What has changed though is that I'm adding a warning message under the certificate fingerprint if it has an invalid signature or an expired certificate. So for example, if we look at the key details, we can see that the Fedora Secure Boot CA, which issued the Fedora Secure Boot Signer, so the Fedora Secure Boot Signer is actually already not valid. So if we attempt to trust this image, we will of course showed with a warning that we can't add this certificate because it's already expired. So what we can do is either do not trust this certificate, or we can just skip it. The next certificate in this image is already the Grab2 signer, which was, for example, issued by Fedora CA, and this one is valid until 2037, so we can, for example, trust this image without issues. Next, we have the Grab bootloader of the Dasharo toolsuite operating system, which is used by the Dasharo team to perform various firmware-related tasks, and this image is unsigned. This warning is also displayed here under the image hash, so we can either trust this image or its hash, or simply add the hash to untrusted database. So let's say, for example, that we want to trust this image. Okay, it must take some time. And now we have more of those certificates that are, for example, invalid. Again, Fedora Secure Boot CA. These are just sample images just to show you how the application works. But now we can skip them because these are the same keys. And once we look through all the bootloaders, the wizard will prompt us to finalize the provisioning process by generating an ephemeral PK and naming Secure Boot. Okay, so that ended up successfully, and now it will boot the first bootloader that we actually trusted. In this case, it will be some grab from Fedora. Right, and as you can see, we have the grub shell because I don't have any operating system. These are just raw bootloaders without any operating system components in the test image. Alright, so time to describe what new has been added. For example, if we enter the Secure Boot configuration menu and then launch the Sovereign Boot wizard, we will be presented with the new view, which I call the interactive mode. So this is the mode of operation of the wizard that allows you to granularly modify the trusted or untrusted key image databases. And this view is only available once you have provisioned the Sovereign Boot. So it won't show up until you actually go through all the bootloaders and finish the provisioning process. So this view has three major submenus. First one is responsible for modifying the bootloader settings. Second one is simply for manipulating the trusted key or image database. And the third one is for manipulating the untrusted key or image database. So let's see how the bootloaders menu look like. So when you enter this menu, you will be presented a list of all UEFI executables that were actually detected on all disks that are currently connected. The assumption is that the files need to have the UEFI extension in order to be properly recognized as a valid bootloader. And if we, for example, check the first boot entry, because we booted the first trusted bootloader, it was set as a first boot priority. That is why it is listed as a first entry in this list. And because the bootloaders that appear on this list first are taken from the boot order variable from the UEFI system. And for example, this is a slightly modified view of the bootloader details that you saw during the provisioning process, but it has some additional fields that represent its attributes or state. For example, we have a couple attributes of this bootloader. For example, if it is signed or if it contains an invalid signature, where the invalid signature may mean that the certificate is expired or the verification of the signature doesn't succeed for some reason. Then we have also some indicators whether this bootloader is, for example, signed by only by Microsoft certificates, or if it contains any Microsoft signatures or certificates. And then we also have some status information whether we have added the hash of this bootloader to any of the databases. And lastly, there is a state indicator whether a given image is trusted. This attribute actually depends on a couple factors. First, whether you have added any of the certificates to the trusted database. So, for example, in this case, it would be either the Fedora Secure Boot signer or grub2 signer, or if you have added the image hash to the trusted database. But also the image will be trusted only if none of the certificates and the image hash is not present in the untrusted database. So for example, if we decide to add the image hash to the untrusted database, it will automatically change the state, right? So now we have the image hash present in the untrusted database, so automatically the whole image cannot be trusted any longer, despite we trust the certificate, one of the certificates present in this image. We can also freely remove this hash from the untrusted database, or for example, let's give it a second because flashing takes a while. Alright, and for example, you can add some image hash to trusted database, for example, but this already doesn't change the state of the trust because we have one of the certificates already trusted. There is also an option to remove all possible hashes or certificates that are present in this image from all databases to reset the state to undecided. For example, if I press this button, as you can see, the image is no longer trusted, neither is untrusted, so we have like a clean state where we would, for example, want to provision the sovereign boot, so this would happen. Of course, if we have a secure boot enabled and this image is neither in the trusted nor untrusted database, then the verification will fail anyways. But for visualizing whether we have given an explicit decision about given bootloader, I'm just showing you that this image is currently undecided whether it is trusted or not. If we enter, for example, one of the certificates, we can also see the information about the certificate, which we could also peek into during the provisioning process. But I additionally give you the certificate fingerprint and also a couple of attributes, which is the certificate validity, so whether it is expired or not, whether the certificate belongs to the Microsoft, so one of those Microsoft Secure Boot certificates, and whether the certificate is present in one of the databases. And we can, of course, choose whether we want to add the certificate to any of those databases. So, for example, if I add back the grab2 signer back to the trusted database here, so the state changed, and we can see that this certificate is already trusted, and we can remove it back from the trusted database if you want, but we also can add it to the untrusted database. So, as you can see, the image trusted has changed to yes because we have trusted one of the certificates. We can, for example, add this image to untrusted and trusted database. And now, to present you the third functionality, I will remove all possible hashes and certificates from all databases. Okay, it will take a while. It's QEMU is slower than the real hardware. And now we can see that the grab2 signer certificate is no longer present in any of the databases. So let's add it back for now. And let's move to another view. For example, if we choose an image that is not signed, we will be presented with just an image hash and options to add the hash to one of the databases or remove it. Then let's move to the trusted image database modification menu. And this menu is very similar to what you see in usual Dashara or upstream Tiniest or EDK2 Secure Boot menu. It allows you to enroll or delete a signature in a more fine-grained manner. So, for example, we can enroll some signature using a file, and I have some sample files here, like the all Microsoft certificates for Secure Boot and the Dashara sample Dashara PK file that is just a placeholder key for enabling Secure Boot purposes. So, for example, I will choose the PK. As you can see, there is one extra certificate here on the list that we just added. So we can also have a more detailed view of what is in our database thanks to the new extensions of Secure Boot. So we can, for example, check out the list here, and then we have an option to delete all signature data in a given list, or we can just peek into the details of given entry inside the list. What is also new, which I added in the Sovereign Boot wizard, is the owner GUID comparison, and in the right top corner you can see whether given entry is like enrolled by Sovereign Boot wizard, or was added by the firmware setup, or was simply added or is simply controlled by, for example, Microsoft. In this case, this entry was added by the Sovereign Boot, so it is indicated so. And if we enter for example, this entry, we can see what kind of hash it is and what is the data of the signature. You can, for example, remove this hash from database, confirm, and now it is gone. Then we have those certificates, for example, the grab2 signer that we chose to trust earlier, and we can also remove this certificate from database if we wish to. And now this is the Dasharo PK, which I added as a trusted. But of course, for the presentation purposes, I can just remove it, for example, like this, and it's also gone. The delete signature, of course, is also a more fine-grained menu to where you can, for example, quickly remove those certificates without excuse me, without peeking into much details. But let's skip it for now. I will show you how this works with untrusted key in database. So by default, the sovereign boot doesn't touch the firmware's default DBX. So if you didn't untrust an image, it will still contain the single list with all the SHA-256 hashes with the default DBX, which can be downloaded from UEFI.org site. So here we can also browse the entries like in previous menu, and you can see in the top right corner that the owner GUID indicates that this DBX entry comes from Microsoft, and we can also freely remove any of those entries, or we can simply, for example, we can simply remove all of those entries at once. If we choose the fine-grained menu, we can also enter this. You can check a couple boxes and, for example, delete only the checked data if we want to. It's also possible to enroll new entries using the enroll using file option. For example, we can let's untrust one of those Microsoft certificates. So this is very much the same as the ADK2 Secure Boot menu offers, where you can choose what kind of type of the entry you want to enroll. So you may enroll a whole certificate or just its hash and revocation time. But let's, for example, commit only whole cert. Okay, and now it appeared in the list of the signatures, so we can also pick into it, and you can see it shows us the common name of the certificate as an entry name. And if we enter here, we can see that this is the new Microsoft UEFI CA from 2023, and we can remove the certificate if we want to. Alright, and if we do any modifications in one of those two databases, those should be also reflected in the bootloaders. But I'm not sure if I have any of those newly signed. No, probably not. I just have the old Microsoft UEFI CA 2011. But we can quickly add this with file UEFI CA 2011. That's probably this one. Okay. Alright, and now if we choose any shim bootloader, it is already indicating as not trusted because the UEFI CA is present in untrusted database. So this pretty much concludes what is new. We also fixed a couple of issues with the previous versions of Sovereign Boot, where, for example, the Sovereign Boot Wizard didn't boot actually the first trusted bootloader, but actually the last one. And the second bug was that when, for example, you were prompted by the Sovereign Boot Wizard during verification failure, it would not add the image as trusted if the image was previously untrusted. So now the support for removing the image from untrusted database has been added, and the trust state can be now overridden and the image will boot properly. Feel free to check our release notes on the docs.shower.com page, where you can find more information about the changes made in this version. So thank you for watching, and as usual I encourage you to leave feedback on the Shower Issues GitHub page. Feel free to open your concerns, or if you find any bugs, please also describe them and we will try to address them properly. Thank you.